Okay, so we've got the notion of a subgroup. H is a subgroup of G if X and Y are in H implies that X, Y minus 1 is also in H. So my examples, I'm going to give a whole raft of examples. Let's consider the real numbers under addition. That's a nice group. I think we've seen it before. And I'm going to consider the integers, which is the set containing 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. I'm going to consider the integers also under addition. Well, it's clear that Z is a subset of R, simply because everything that's in Z, everything that's an integer is a real number as well. But let's see if we can verify the group axioms. So if we've got X is a member of Z, then X to the minus 1, is that in Z too? Well, if X is a member of Z, then X equals, let's call it N, then X to the minus 1 equals minus N, which is also a member of Z. That's assuming N is positive. If X equals minus N, then X to the minus 1 equals minus minus N, which is of course equal to plus N, which is also a member of Z. And the other one is X equals 0, I guess, in which case X minus 1 equals 0 as well. Observe here that I'm using multiplicative notation. The notation to the power minus 1 kind of implies that I'm multiplying my numbers together, and I'm not, I'm adding them. We're looking at the numbers under addition. So the notations are perhaps a little bit confusing. However, we've established now that whatever X is, if X is in Z, then X to the minus 1, the inverse of that, is also in Z. So that's the first one done. Sorry, a little bit of a glitch there. So we've established that if X is in Z, then X minus 1, which is minus X, is also in Z. The other one we need to check is this. If X and Y are in Z, then X, Y minus 1 is in Z. Is that true? Well, whatever X and Y are, X and Y, then X, Y minus 1 equals X minus Y, which is one integer, subtract another one, which is of course also in Z. So that's the second rule proved. So we've established that Z, treated as a group, is a subset of R. That's nice. I'm going to stop there.